everyone. I am Dr. Moumita, Head of the Department of Physics at MS University. It's been almost 5 years since I joined here, and during this time, being a theoretical physicist, I have taught many theory papers like classical mechanics, quantum mechanics, many body theory, condensed matter physics, electrostatics, and also computer programming oriented lab papers like simulation lab in postgraduate program, quantum mechanics lab in undergraduate program, and so on. So as a teacher, I enjoy teaching every courses, and there is no bias. But as a physicist, one of my most favorite subject is undoubtedly quantum mechanics. And I teach this subject at postgraduate level. And today I am going to talk about this subject. So firstly, what is quantum mechanics? Quantum mechanics is one of the most significant theoretical formalism in physics, which tells us how nature works at microscopic level. See, if I look around us, it is classical mechanics, classical physics mostly everywhere. And by classical physics, I meant classical mechanics, thermodynamics, electromagnetism, optics, etc. Basically, the world we perceive through our naked eyes is completely governed by Newtonian mechanics. Here, the world is extremely deterministic. And what is meant by that? It means that, say, if I know the position and velocity of an object, say a ball, at any time, then I can predict its position and velocity at any other time, provided that I know the total resultant force acting on that object. And this is the basic essence of Newton's law. And it has much more applications, complex applications than this, but things work completely differently at atomic and subatomic level. Unlike the ball, here, for that matter, we cannot predict the position or say momentum of a subatomic particle, say an electron, with 100% precision. This is not possible. And that is why quantum mechanics is conceptually an entirely different theoretical formalism that explains almost every atomic and subatomic level phenomena at non-relativistic. In our postgraduate program, the entire syllabus is spanned over 2 semesters. In the first semester, we mainly focus on the fundamentals, that is mathematical formalism, bracket algebra, matrix mechanics, and then application of Schrödinger equation in 1 dimension and higher dimensions as well. And finally, a different concept of angular momentum and spin. And then in the next semester, we focus on the more advanced part, which is various approximation methods to solve analytically unsolvable potential problems like WKB approximation, variational method, and of course time-independent perturbation theory. Then time-dependent perturbation theory, quantum mechanical scattering, symmetries in quantum mechanics, etc. And finally, we end with why quantum mechanics doesn't work in relativistic regime and why quantum field theory is required. So that was a very brief outline of the entire syllabus that we teach here in MS University. And as far as teaching methodology is concerned, we believe in what Aristotle once said. He said that we are what we repeatedly do. Excellence then is not an act, but an habit. Similarly, if a student expects to learn quantum mechanics just by reading books, he or she is absolutely wrong. I mean, it's like learning swimming just by watching others swim. This is not possible. Similarly, quantum mechanics cannot be learned passively. Unless and until a student tackles different challenging problems, he or she will not be able to estimate his or her understanding in the subject. So that's it. You have to just solve a lot of challenging problems. And finally, the applications of this subject or the scope. Actually, quantum mechanical concepts are required everywhere, from solid-state physics to nuclear physics to atomic and molecular spectroscopy, quantum optics, many-body theory, and whatnot. Actually, it is almost impossible to name any active research area in physics where quantum mechanical concepts are not required. Even it is essential in different multidisciplinary research fields like nanoscience and nanotechnology, quantum computation, solid-state device engineering, spintronic engineering, etc. So in short, quantum mechanics is a subject with unmatched potential and unimaginable applications in different areas in physics. So that's all for today. So I urge the students, if you are interested to know about the entire curriculum, please visit our website. It is www.adamusuniversity.ac.in, and you can go through the entire curriculum. It is given there. And I have also another request, that I know it is not possible for you to visit our labs physically right now during this lockdown. So if you are interested, you can witness our virtual lab facility given in our website. I think you will be interested to know that. And lastly, I want to congratulate, before I end, I want to congratulate all the members of Adamus University, both academic and administrative, for being able to continue to do what they usually does with an undisturbed flow, even in the face of such a crisis, which is all across the world. Actually, it takes a lot of effort to maintain the standard of academics. And I believe this is the backbone of any academic organization. So I hope that we all shall overcome this tough time with our patience and dedication. Thank you.